Good morning dear student. Once again I welcome you in this next session of the data warehouse. Already I have covered some of the introductory points from what is data warehouse in the first lecture. In this lecture I will cover the data warehouse architecture. In figure you will find a data warehouse architecture which contains three major tiers. The bottom tier in figure, focus on figure, the bottom tier is warehouse database server, which is always a relational database system. The middle tier is an OLAP server that is typically implements using either a relational OLAP, that is OLAP, or a multidimensional OLAP, that is OLAP model. The top tier you will find on top of this architecture, data warehouse architecture, you will find the top tier, which is a front end client layer, which contains a query and reporting tools, analysis tools, or data mining tools. For example, here you will find some of the trend analysis, prediction, and so on. Before explaining the entire structure, I will focus on the backend tools and utilities. Here you will find in figure at the bottom end, means below bottom tier there is a arrow, you will find there is a extract, clean, transform, and load and refresh is there. So, here in backend tools and utilities which are used to feed the data into the bottom tier from operational databases or other external sources, means if you want to construct the data warehouse, here very important role, that is backend tools which plays for constructing the proper data warehouse. Here what is about the extract, clean, transform? Very simple things. Extract means you have to extract the information from heterogeneous platforms or from different sources, might be kind of different data structures, different data types. So, here you can extract the heterogeneous platforms, heterogeneous sources. Then clean, clean is nothing but the data cleaning, which detects some of the errors and rectifies them when possible. Transform, you can transform your data, legacy data, into the proper data warehouse form. Load, load is nothing but which sorts, summarizes, consolidates, computes, views, checks integrity, and builds indices and partitions. And finally, there is a refresh, means all these utilities if you are able to perform while constructing the data warehouse, it is somewhat you are constructing a proper data warehouse. And in refresh, which propagates the updates from the data sources to the warehouse. Already I have explained all these things. In data warehouse model, here we have to focus on three different models which covers the data warehouse. Here you will find the enterprise warehouse, data mart, and virtual warehouse. As far as enterprise warehouse is there, it collects all of the information about the subject spanning the entire organization. It provides corporate wide data integration. It contains detailed information or detailed data as well as summarized data and range in size from hundreds of gigabytes, terabytes or beyond. What is about the data mart? Data mart is nothing but it contains a subset of corporate wide data that is of value to a specific group of users. The scope is confined to specific selected subject only. For example, a marketing data mart may confine its subjects to customer, item, and sales. It contains detailed data as well as summarized data. See here, it is not up to the detailed data. Here we can form data mart which forms the summarized data or might be in range in size. Third data model or data warehouse model is the virtual warehouse. It is a set of views over operational databases. For efficient query processing, only some of the possible summary views may be materialized. Means in short we can say, whenever you want to represent your data in a representation form, we can use the virtual warehouse. A virtual warehouse is easy to build, but requires excess capacity on operational database servers. A metadata, again in figure you will find metadata repository is there. What is it? Metadata are data about data, means whatever the data, whatever the terms we are having in our data warehouse, the detailed explanation of these data or these terms you will find under the metadata repository. A metadata should contain the following: a description of the data structures, operational metadata, for example, history of the migrated data and sequence of transformation applied on it. The algorithms used for summarization include measure and dimension definition algorithms, the entire things which cover under the metadata repository, mapping from the operational environment to the data warehouse, for example, which includes the extraction, cleaning, transformation, rules and defaults. Business metadata includes business terms and definitions, data ownership information and charging policies. At the top we focus, that is the top tier, that is the front end tools. Here whatever the data after processing we can gain in the form of data mining or extracted data, might be in the form of analysis, might be in the form of query, reports, graphs. So, here at the top of this data warehouse architecture you will gain the output of the data. Here I will explain typical OLAP operations. So, now here you have to focus on what kind of operations we can easily operate on OLAP. So, here you will find there is a slice operation is there, dice operation is there, rotate operation is there, drill down operation is there and pivoting operation is there. As far as slice operation, name itself says that whenever you want to acquire the data by selecting one dimension, simply we can select one dimension and you can acquire your own or desired data. That is a kind of slicing operation, means simply you can select or you can choose a one dimension and accordingly you can acquire the data. Dicing operation, name itself says that if you are using more than one dimensions to acquire the data. So, here you can acquire the data by selecting more than one dimensions. For example, we are selecting location, we are selecting item or by selecting time, means here more than one dimensions we can select to acquire our desired data. You will find there is a roll up operation is there. In roll up operation we can gain the information in the form of aggregation. See here in example you will find in the figure there is a time dimension is there, quarter 1, quarter 2, quarter 3, quarter 4. Instead of this, by selecting a specific quarter, quarter 1, quarter 2, we can select this information in the form of year, which will aggregates the entire coordinates, entire quarter 1 to quarter 4. So, that is the aggregation we can gain here in the form of roll up operation. On the other hand, you will find drill down operation is there, in which you can gain the information in a detailed form, means instead of taking the information from quarter 1, quarter 2, quarter 3 or quarter 4, you can select the specific month, you can select January, February, March and from these specific month you can acquire the information. So, in this way we can operate or we can gain the information in the form of OLAP operations, slicing, dicing, roll up, drill down. One more operation is there, you will find pivot. Pivot means if you want to acquire the information in the form of representation or views, simply we can select some of the dimensions, some of the attributes and accordingly we can gather the information. So, that is a kind of pivot which plays a very important role in the at the time of representing your data. So, already I have explained the roll up operation, which is also known as a drill up operation, which performs the aggregation on a data cube either by climbing up a concept hierarchy for a dimension or by dimension reduction. Drill down operation, it is the reverse of the roll up, it navigates from less detail to more detailed data. Already I have highlighted on slice and dice operation and pivot operation. So, today I will conclude today's lecture. Thank you for watching.